Hey, today we're going to be talking about inclined planes, specifically the inclined planes used in starting blocks.
An inclined plane, also known as a ramp, is a flat, supported surface tilted at an angle with one end higher than the other.
They are used as an aid for raising or lowering a load. The inclined plane is one of the 6 classical simple machines defined by Renaissance scientists. It is unknown who the first person was who invented it.
The first recorded use of an inclined plane in construction happened around 2600 BC when ramps were used in the construction of the Great Pyramids.
Competitive blocks were first used in international competition at the Swimming World Cup in 2009. They let swimmers push off from a crouch with the rear leg at a 90-degree angle, optimizing the power of their launch.
Okay, so we did a sample problem to find the power and the difference in power from jumping off a flat surface and the power jumping off an inclined plane. So the givens we have for this problem are that mass is 60 kilograms, force is 588 newtons, which is found by multiplying 60 by the acceleration due to gravity, which is 9.8. And then we timed it, and time from launch into water is 2 seconds, and the distance is approximately 3 meters. So those are the givens for this problem, and then really we just have to plug them in. So here is the calculations off a flat surface or level surface. So we assume that you have to jump up 588 newtons to counteract the force of gravity. And then you jump in this kind of parabola shape in an arc. And the work equation here, work times mass, distance, and then the cosine of 180, which is -1. So then work actually comes out to be negative, which makes sense because you're pushing off in the opposite direction of your movement. You're pushing down on the ground and you're moving up. And then power, we took work and divided it by time in seconds. So the work exerted by the swimmer jumping off a level surface is 882 watts. Similarly, we did calculations jumping off an inclined plane. However, this time the incline is 10 degrees, so we adjusted calculations accordingly and found that at the end of all this, the power from jumping off a level surface here, 882 watts, is more than the power needed to jump off an inclined plane, 868.6 watts. So therefore, the block provides a mechanical advantage to the swimmer. Now, we calculated the IMA over here on this whiteboard. All right, then to calculate IMA, we used the formula for IMA of a wedge because block is a kind of a wedgy shape. So IMA for a wedge is the length of penetration divided by the depth of penetration. So following the same logic, we solved for those values in our diagram of the block here. This is ground level. I don't know that it matters, but the block is 88 centimeters from the ground and then 70 centimeters from the ground in the front, so you obviously have that 10-degree angle. The length of the hypotenuse of the block is 80 centimeters. So then using trig, we found the length of penetration and the depth of penetration, or x and y. So to solve for x, we used cosine. Calculations are drawn accordingly. And then for y, we used sine. And again, calculations are here. So then, to finish up, we found the IMA over here by dividing 78.78 by 13.89, and found that there's indeed a mechanical advantage. Then for power, wrong project. Okay, so then for power and energy calculations, we found using our calculation of power and from up here and weight and all that, we found the potential energy by using the mass and acceleration of gravity, which we already calculated in newtons, is 588. And then we multiplied it by as shown on the diagram previously of a block, that it's the height of the block is 0.88 meters. So we multiplied that out. Found that potential energy was this. Then, using the logic that work in equals work out, you can say that potential energy will eventually equal kinetic energy. So therefore, kinetic energy is the same as potential energy, 517.44.
Excuse me, I thought there were going to be slides.
Yes! Let me direct your attention to this whiteboard over here.
Pretty sure I'm done with this.
What am I supposed to do?